Hello students, so for the last few videos we have been beginning our journey of graphing rational functions. We've talked about vertical asymptotes and horizontal asymptotes and holes in the graph. We haven't actually graphed one of these functions yet. We're just kind of getting all these little pieces together first before we put the whole thing together. We are moving on to what I'm calling 4C.2, but we're still trying to graph these functions. And today I want to talk about another type of asymptote, the third type of asymptote that you sometimes see. It's called a slant asymptote or an oblique asymptote. And we'll call it a slant asymptote for the most part. But if you ever see that oblique asymptote, that's the same thing. So we've talked about vertical or up and down asymptotes and horizontal or left and right. Now we're going to add the ones that are slanted, and we've got to figure out how to graph those, how to find them when they show up. So these types of asymptotes show up when the degree of the numerator is exactly one larger or one greater than the degree of the denominator. And when this happens, we often end up with what's called a slanted asymptote. To find the slanted asymptote, we're just going to divide the numerator by the denominator. You can use synthetic division if that's an option for you, and when that's not an option, then you have to use long division. Whenever you're doing this, as you'll see in a little bit, we do ignore the remainder. If there is a remainder, we don't include it. Once we've done the long division or synthetic division without the remainder, that's going to be our answer. That's going to be our equation, our slanted asymptote. You'll notice that we have been using the same examples for the last several videos. Well, what's going to happen today is none of these examples actually have a slanted asymptote because their degrees just don't work out that way. So if there is a horizontal asymptote, there's not a slanted asymptote, because remember, the horizontal asymptotes required either the degree to be the same in the numerator and the denominator, or the degree to be less in the numerator than it was in the denominator. And that's when you have a horizontal asymptote. Slant asymptotes happen when the degree in the numerator is larger than the degree in the denominator, specifically one larger. So all of these examples that we have kind of been working through slowly, they're not going to work because none of them have that situation happening. So we can kind of scroll through them very quickly because none of them have anything that we can work with. Even the extra examples that I've added still have the same problem. Now, we do have an extra example number 2 that you might have in your notes somewhere from the last video if you want to find that. The degree in the numerator is 2, and the degree in the denominator is 1. So you would think, well, this one might have a slanted asymptote, but this one turned out to have a hole in it. So when we factor the numerator and the denominator, the x minus 5 canceled out, and we ended up with the equation y equals x plus 3. Well, this is the reduced form, which means that that's our function. Our function is linear, right? This whole thing reduced to just be x plus 3. So you can see I've added that line up here. I started at positive 3 on the y-axis because there's a y-intercept at 3, and then I went up 1 over 1, up 1 over 1 to get that slope of 1 in front of the x. And I end up with this line. And remember, the one thing about this special graph is that it had a hole at 5, 8. That's what made it unique. So this rational function turned out to be a linear function with a hole. And that's kind of cool, but still no slant asymptote. So we're going to have to look at a few more examples that are not in your guided notes that you're going to have to add on to your notes somewhere else, and we'll get to those right now. So the first question says to find the slanted asymptote. Let me make that a little bigger. To find the slanted asymptote of f of x equals x squared minus 4x minus 5 over x minus 3. Now, before we jump in to find the slanted asymptote, let's review the things that we've already talked about. First, let's find the vertical asymptotes. And how do we find the vertical asymptotes? Well, what we did is we factored the top and the bottom. So if we factor the top and the bottom, our numerator is going to factor to become x minus 5 times x plus 1. That way we get negative 5 times 1 gives us negative 5, and negative 5x plus 1x is negative 4x. So factors nicely. In the denominator, we get x minus 3. This time, nothing cancels out, right? So we don't have any holes, in other words. So we can go ahead and write that over here. Holes? Do we have them? No. There's not going to be any holes because nothing cancels out. But we do have an x minus 3 in the denominator, and that's where we get our vertical asymptote. Once we've factored and made sure that there are no holes, we set the denominator equal to 0 to find the vertical asymptote. And this vertical asymptote happens to be at x equals 3. So that means we're going to have an up and down asymptote at x equals 3. These vertical asymptotes are no joke. The function will not cross them. There's no way, right? This is a line across the graph that cannot be crossed. The horizontal asymptotes happen when the degree in the top is the same as the degree in the bottom, or the degree is less in the numerator than it is in the denominator. That's not happening here, so we have no horizontal asymptote. There's none of those either. What we do have is what's called a slanted asymptote, because the degree is 2 in the numerator and 1 in the denominator, and 2 is exactly 1 greater than 1. Since this is the case, we are going to look for and try to identify the slant asymptote. To find the slant asymptote, I can either use long division or synthetic division. Well, in this case, I'm dividing by x minus 3. Synthetic division is going to be the easiest way to go, and you might have to take a second here to remember how to do that, but you'll probably remember it was pretty easy. We start with 1 in front of the x squared, negative 4 in front of the x, negative 5. We are dividing by not negative 3, but what the solution to x minus 3 equals 0 is. We're dividing by positive 3. Remember, x minus 3 would be a factor, 3 would be a solution, and we divide by the root of the solution. Okay, so with synthetic division, we bring down the first number. We multiply 3 times 1. Negative 4 plus 3 is negative 1. So we add down, then multiply. And this last number ended up being what we call a remainder. Okay, now remember that we started with a quadratic and divided a linear. Basically, we started with a degree of 2 divided by a degree of 1. So that leaves us with a degree of 1. This is going to be y equals 1x minus 1. Ignore whatever the remainder is. It doesn't come into play with the slant asymptote. So basically what's going to happen on our graph is we're going to have a slanted line that's going to go through the y-axis at negative 1 and have a slope of 1, and it's going to kind of go up the graph. I'm going to go ahead and show you what that looks like here. Get this thing off. All right. So remember we said that there was a vertical asymptote at 3. Here it is. This is never going to be crossed. Okay. We have a slanted asymptote that goes through negative 1 on the x-axis and has a slope of 1, and you can see that happening here. So we've got our slanted asymptote. You can see why it's called a slant asymptote, because it's slanted. Remember, you can also call it an oblique asymptote at y equals x minus 1. Now, these slant asymptotes usually are going to be like a regular asymptote. Your function is going to approach it, but never cross it. But that's kind of a suggestion sometimes. I mean, sometimes what will happen is your function will cross your slant asymptote. There's nothing you can do about it. You may not like it. Oh well, too bad. It's going to happen sometimes. When it happens, generally speaking, even though it's going to cross that asymptote, it's going to kind of hug close to it, stay close to it forever. So it may go cross it. Don't freak out if that happens. It's okay, but it shouldn't be like wackadoo. It should still kind of be close to that slanted asymptote, even if it crosses it. All right, so I've got one more example for you today. The last example, we were able to synthetically divide. This time, we are not going to be able to synthetically divide. So instead, we're going to have to use long division. So this is something that students either love or hate. You just got to do it. All right, so remember, we put all of the terms in order. X to the third plus 2x squared plus 5x minus 9. That's our numerator, and we're going to divide by x squared minus x plus 1. Now, when you do this, kind of have your little scratch paper off to the side. We take our first term for each one of these. This is going to kind of come back to you, and we divide. So x to the third divided by x squared is just x. And I always line that up over the thing that is an x term here, so I just put it right there over the x. All right, I multiply, so this is the first step. Divide x squared minus x plus 1 into the first three terms just by looking at that leading term, right? Then you multiply x times all three of these things. That gives me x to the third minus x squared plus 1x. And then we subtract. And subtract means changing all of the signs so that you are subtracting everything. So when you subtract a negative, you actually add. When you subtract a positive, you subtract. So all of the signs change, and then you add down, I guess. Right? So the first term should always cancel out when you do this. The next one, we've got 2 plus 1 is 3x squared. 5 minus 1 is 4x. And then we bring down the minus 9. Again, we are only going to be looking at that first term over there. So, and this first term here. So we're going to divide 3x squared by x squared. And the x squareds cancel out, leaving us with just 3. So that's going to be a positive 3 that I get when I divide 3x squared by x squared. Multiply that 3 times all three terms. This is just like long division when you were in the 3rd or 4th grade, maybe a little different, you know, because you have all these x's, but it's very similar. So 3 times x squared is 3x squared, 3 times negative x is negative 3x, and 3 times 1 is 3. In order to subtract, I have to change all of these signs. So any minuses become positives, and any pluses become minuses. And then I add down, or subtract down, as it were. So the first one cancels out. 4 plus 3 is 7x. Negative 9 minus 3 is minus 12. Now remember, when we divided this before, what we would do is we would say, oh, okay, 7x minus 12 is going to be over x squared plus x plus 1, right? So this would be the answer when you divide it. But when we are finding slant asymptotes, that remainder there, that last thing that you get, we ignore. Ignore it. We don't need it. Instead, we only use the x plus 3, and that is going to be our slant asymptote. Our slant asymptote is going to be y equals x plus 3. All right, now let's look at the graph and see what this looks like. This function is going to look kind of funky. All right, so we go through the y-axis at positive 3. We have a slope of 1. That is this line right here. And I want you to see what happens with this function is it does this little dip here, you know, but it does something that we don't want it to do. Because we've been told that asymptotes cannot be crossed, but these asymptotes sometimes can be crossed, and this one is. But notice that it does follow along pretty closely. Even though it crosses it, it's going to kind of stay close to it. They're going to stay friends. They're not going to split up. They're going to stay together. They just might not act like a true asymptote at all times for the entire graph. I hope that makes sense. Really, the only thing that you have to remember for slant asymptotes and how to find them and how to graph them is look for times when the degree in the numerator is 1 more than the degree in the denominator. Either synthetically divide or long division. And once you do it, graph that line on your graph as a dashed or dotted line, and your function should either not cross it or cross it but kind of hang out next to it. That's it. That is slanted asymptotes. If you have any trouble as you begin to see these types of problems and practice them, please let me know in class. I'd be glad to help you out.